Before we get into making use of inverse trig ratios, we have to understand some of the vocabulary that you might hear in dealing with this. So if we talk about the inverse sign, okay, in other words, the opposite or reverse operation of a sign, it's the same as also calling it the arc sign. Okay, so if I say what's the arc sign of 1/2, it's the same as saying what's the inverse sign of 1/2. Okay, in written form you might see it like this. So if you see this in writing, you could say, well, that's the arc sign, or that's the inverse sign of some value. And just keep in mind, those two things are different than this. And some people get confused where they think, okay, the inverse sign just means it's the reciprocal. This isn't the reciprocal. What you see over here is a special type of ratio, and we're going to talk about that. You'll talk about that more in Algebra 2. But this is not the same as saying inverse sign or arc sign. Okay. Remember, inverse trig ratios are talking about a specific value. So if you talk about the tangent of an angle, it gives you a value. If you're talking about the arc tangent or the inverse tangent of a specific value, it'll give you an angle measurement. That's the idea of the reverse operations that we've already talked about. So let's start putting that into practice now. In this case, we're looking for the measure of angle A. Before, when we were using trig ratios, we had an angle that we knew about, and it helped us to find side lengths. So here we're using inverse trig ratios, the arc sine or inverse sine or arc cosine or inverse cosine, whatever you want to call it. We're really trying to find a missing angle measurement based on given lengths that we already have. Okay, so looking at angle A, we have to recognize that's what we're going to call our reference angle. And so I've got a couple questions down below as I'm beginning. What's my reference angle? Well, it's angle A. So we have to identify that. And then identify which sides you actually know about. Do I know what the opposite is? Do I know what the adjacent or hypotenuse is from that reference angle? Well, I know the opposite side is 6. So I'm going to say opposite, I know. And I know the hypotenuse here is 10. Okay, so it's the opposite and the hypotenuse that I know something about. So based on those sides, which trig ratio would I use? And again, you're thinking back to SO and CA and TOA, and if I've got the opposite and the hypotenuse, I'm going to use this trig ratio here of sine. Now, in this case, we're going to use the inverse of sine. You'll see that in a second, but it's based off of sine. Okay, so knowing that that's the case, and knowing that am I going to try to find a value? No, I'm not. So I'm not going to use sine, cosine, or tangent. Eventually, I'm going to try to find that angle measurement of A that I'm missing. So I'm going to use the arc sine, or if you want to call it inverse sine, that's fine. I know I'm going to use the inverse sine, guys, but I still need to set it up as if I'm using sine, because I know that the sine of angle A is the opposite over hypotenuse. The opposite in this case is 6, the hypotenuse is 10. Okay, so the problem with finding this, and I could simplify that if I wanted to, I could call that 3/5. The sine ratio of this angle in here, this reference angle, is 3/5. So what? It doesn't tell me anything yet, because I want to know what that angle measurement is. Is it 27 degrees? Is it 54 degrees? So here's where we can bring in that arc cosine. Okay, to undo something, like to undo addition, you subtract. To undo multiplication, you divide. And so here's the same thing. To undo the sine of an angle, we're going to take the arc sine of all of it. Okay, essentially what that's going to do, the arc sine and the sine are going to cancel out in a way, so we're going to be left with just the angle A, and that's what we're looking for. But just like we've done in everything else in algebra to keep the equation balanced, if I did it on one side, I've got to do it on the other side over here. What's the arc sine? Sorry, kind of sloppy there. What's the arc sine of 6/10? Okay, so when I take the inverse sine of the sine of A, those essentially just cancel out, and I'm left with A, or if I want to call it the measure of angle A, I could do that. Over here, I'd have to plug into my calculator the inverse sine of 6/10. And when I do that, maybe I'll rewrite it down here first. The inverse sine of 6, inverse sine, so it looks like a little -1 up there, of 6/10. When I plug that into my calculator, I found out that angle A ends up being 36.9 degrees approximately. That's what this angle is, which I know about because I have these measurements. So again, using that indirect measurement concept. Let's try another one on the next page. Here we're trying to find the measure of angle A, okay? So that means the measure of angle A is my reference angle. And thinking through those steps that we talked about before, what sides do I know about? Well, this is the hypotenuse. I don't have that one, but I do have the opposite side, and I do have the adjacent side here. And if I think through SO, CA, TOA, the one that uses O and A is tangent. So I'm going to start by saying I know something about the tangent of angle A. The tangent of angle A should be the opposite over adjacent, TOA, right? The opposite in this case is 15, and the adjacent side is 20. So now to find the actual angle itself, I want to find A, right? I don't want the tangent of A, so I've got to undo the tangent by taking the arc tangent. And if I do it to one side, I've got to do it to the other side. Okay, what I get when I do that, arc tangent and tangent essentially cancel out. I'm left with A. So A must equal the arc tangent of 15/20, or if you want to call it 3/4, that's fine. And when I plug this into my calculator, making sure that it's on degree mode, not radian mode, I get A as a angle measurement of 36.9 degrees. Okay, so the same angle that we saw before is here. Let's try two more, and what I would suggest that you do in this case is actually I'll do one side and then the other side. Maybe pause the video and see if you're at the point where you can try this on your own already. Okay, so in this case, knowing that the sine of A is 0.87, I can solve just by doing one step in my calculator by taking the arc sine of both sides, and that'll get me my measurement for angle A all by itself. The reason for that is because the arc sine and the sine cancel out, and I'm going to be left with A. Okay, so I could say that A is the arc sine of 0.87. The reason that I can say that, and that gets me a value, by the way, that gets me a value of 60.5 degrees. Okay, the reason that it's okay for me to say that angle A has to be 60.5 degrees is because it is the angle that has a sine ratio, which is the opposite over the hypotenuse, right? That's sine. 60.5 degrees is the angle that has a ratio of 0.87. That's what makes this angle A 60.5, okay, based on the equation that we began with. Okay, so that's kind of just thinking through the logic of why and how these inverse trig functions are the reverse operations of trig functions. All right, so see if you can fill out the right side on your own. I'd suggest that you pause the video right now. I'll give you a second to do that. And now looking at the right side, in order to solve for angle B, we would say that if I could take the inverse cosine of both sides, we would be left with B is the arc, whoops, not sine, arc cosine of 0.15. And when I plug that into my calculator on degree mode, gives me a value of 81.4 degrees. So we would say that 81 0.4 degrees is what angle B is, because it is the angle that has a cosine ratio, which is adjacent over hypotenuse, a cosine ratio of 0.15. It's the only angle that has a cosine ratio of 0.15. So therefore, the cosine of B must be 0.15.